Welcome friends and welcome to my series of video lectures on design of steel structures. The topic of this video lecture is Indian Standard Codes and Indian Standard Steel Sections. There are two expected learning outcomes from this video. One, state metallurgical properties of structural steel and enlist major Indian steel manufacturers. Second, draw eye, channel and angle sections and interpret their properties with reference to steel tables. There are some key terms used in the video: low carbon, high carbon, TMT steel, hot rolling and cold rolling, Tata, JSW, SAIL, BIS and IS codes, standard I, channel, angle, T sections, section designations, steel tables, and sectional properties. Now we will briefly see the metallurgy of structural steel. Actually, the metallurgy of structural steel is highly complex and vast, but we will just have a brief introduction. Structural steel is an iron alloy. Alloy means it is a combination of metals. So structural steel is an iron alloy containing less than 0.25% carbon and less than 1.5% manganese and other metals in small proportions. Carbon and manganese increase the yield strength of structural steel. There are three varieties of structural steel. One, mild steel. Second, low carbon steel. Third, high carbon steel. There is another variety called thermomechanically treated, that is TMT steel, which performs better structurally than the ordinary steel, and it has got even higher fire resistance than ordinary steel. Structural steel is designated as Fe415, Fe540, etc. These designations are also called grades of steel. For example, the grade Fe415 represents Fe iron, and 415, this figure represents characteristic value of ultimate stress, Fu, which you may recollect to have appeared in the stress strength graph of structural steel. So that was a brief metallurgical composition of structural steel. Now we see some processes involved in steel section making. Different steel members are manufactured in the factories based on their usage. Rolled steel sections are casted by a rolling process in continuous casting molds without any joints. We know that all the steel structures which we construct, they are made up of standard steel sections which are manufactured in the factories, and they are brought to the site and assembled there as the steel structure. Now there are two processes of rolling which are carried out in the factories while making the rolled steel sections. The first is called hot rolling. So hot rolling is a mill process of rolling the steel at a high temperature, typically at a temperature above the recrystallization temperature, which is over 1700 degrees Fahrenheit. At this high temperature, we can shape the steel in any suitable form without joints. Now, the second type of process is called as cold rolling. Cold rolling process is the process of cooling already hot rolled sections in cold reduction mills, followed by the process of annealing and tempers rolling. This cold rolling is costlier as compared to hot rolling, but the cold rolled sections are superior than the hot rolled sections in yield stress, in surface finish, in tolerance, in concentricity, and in straightness. This diagram illustrates the process of cold rolling and hot rolling. These are two rollers. and these rollers are having at their ends some typical shapes. These shapes are typical for different type of steel sections. So they will be different for I section, different for angle section, different for channel section, and so on. Here at the joint or in between the two rollers, we find the component being shaped. So when the rollers will roll and this component material will pass, this will acquire the shape of the section which we desire. So in this way, this rolling process goes on. Now, here we see a video in which we will be seeing the process of rolling.
Whatever the product, the principles of hot rolling are the same. Steel is squeezed between rolls until the final thickness and shape are achieved. Universal beam mills include stands with both horizontal and vertical rolls bearing on the steel simultaneously. The rolled steel is then cooled in a way appropriate to its end use and prepared for further processing or dispatch.
So that was a video which illustrated briefly the process of hot rolling. There are three major manufacturers of steel in India, and I think we should know at least their names and their symbols or the logos. So the greatest manufacturer of steel in India is Tata Steel. Here we see the logo of Tata Steel. The second is JSW Steel. This is the second. This is of the Jindal Group. And the third is SAIL. The long form of the SAIL is Steel Authority of India Limited. So these are the logos of three major steel manufacturers in India. So this is just an information or introduction for us. As a home exercise, you can visit the websites of all the three manufacturers and make your brief notes. In this slide, we will get introduced to the Bureau of Indian Standards and the concept of Indian Standard Codes. In order to regulate uniformity in quality and procedural standards in any technological field, there is a country-wide standards authority necessary. In India, the Bureau of Indian Standards, which is abbreviated as BIS, is the national standards body working under Government of India. Here we see the logo of BIS. Manakaha Pathadarshakaha is their tagline. Bureau of Indian Standards, that head office is located at New Delhi, and their website is https://bis.gov.in. They offer this ISI mark, which is very popular everywhere. We find on every standard products we find this ISI mark. The Indian Standard Codes, IS codes, are the books published by the Bureau of Indian Standards on the various technological areas to lay uniform nationwide standards of quality. So this Bureau of Indian Standard publishes these books, small booklets, which are called as Indian Standard Codes or IS codes, and they are containing the nationwide standards of quality, and the entire nation is supposed to follow those standards. Every country has its own institutions like BIS and codes of standards. Now we see a brief list of the Indian Standard Codes related to steel structures. The first and most common and most important Indian Standard Code is IS 800-2007, which is for General Construction in Steel Code of Practice. If we look at the designation of an IS code, it consists of three parts. IS means Indian Standards. Then there is a number. This number is particular with any particular subject of IS code. So for steel structures we use IS 800, and next to that there is year of publication. So 2007 is the year of publication of this IS code. So IS 800 2007 General Construction in Steel Code of Practice. So we use this IS code, and in our studies further we will be always referring to this IS 800 2007. There is second Indian Standard Code IS 875 1987. It is in 5 parts. All these 5 parts, they actually belong to the same subject, that is code of practice for design loads other than earthquake loads for buildings and structures. So this IS 875 1987 gives us the standard values of the loads which are to be taken for calculation of or for doing the design of the structure. So this IS 875 1987 part 1 reaffirmed in 1994. So this is on dead loads. If you look at this IS code, it contains the unit weights of about 72 building materials and components. Second is part 2 of this IS 875. It is on imposed loads. Imposed loads are also called as live loads, which are due to the users and usage of the flow of the structure, and this IS code gives us standard values of imposed or live loads on floors, roofs, then the live loads to be taken due to dust, rain, impact and vibration. IS 875 1987 part 3 is on wind loads. The structures which are tall like chimneys or high buildings or roof truss industry sheds, they are all subjected to wind loads, and the entire wind load analysis, the loads are taken from the IS 875 1987 part 3. Then part 4 is devoted to snow loads. Wherever there is a snowfall area, then the snow loads also are to be considered in structural design, and the loads are to be taken from this IS code. IS 875 1987 part 5 is about special loads and load combinations. So these loads will occur simultaneously. Dead load, live load, wind load, snow load, they can occur simultaneously. So their combinations are also required to be considered in design. That is why this part 5 is devoted to load combinations and special loads. In addition to these two IS codes, we are using one more IS code, that is IS 1383 1984. This is particularly devoted to the earthquake resistant design of structures. Then IS 808 1989 and IS 12778 2004. These two IS codes, they refer to the standard hot rolled steel beams, column, channel and angle sections, and also hot rolled parallel flange steel sections, and both of them contain what we call as steel tables. So this was in brief the introduction of Bureau of Indian Standards and the common IS codes used in the steel structures. Now, as a homework exercise, get a copy of the codes from the net. They are available in PDF form on the net, and make your brief notes on each Indian Standard Code mentioned here. The IS 808 1989, reaffirmed in 2004, provides us 8 varieties of standard steel sections, and the dimensions of hot rolled steel beam, column, channel, angle sections are given in this IS 808 1989. 8 standard steel sections. Steel structures are made up of standard steel sections manufactured in factories and transported to steel yards for sale. Erection is done on site using cranes. Now we see these 8 standard steel sections. The first one is I section or beam section. Look at the cross-sectional shape. The cross-sectional shape is like I. The length is not the matter. The cross-sectional shape makes a section different from the other. The second is channel section. We see a C channel in the cross section. Then angle sections. We see angles. These are 4 angle sections. Now there is a T section. We see a T cross section. Then there are round bars. You can see the bars are here, round bars, round cross section. Then square bars. The cross section of bar is a square. Then we have steel plates. We have steel flats also. You can see that the plate is having its width and thickness much bigger than the steel flats. Now these were the 8 sections, and as we said right now, all these sections are manufactured in the factory and they are brought to what we call a steel yard, where steel sections are sold. So you can visit a steel yard nearby your city or your location and see various varieties of steel sections kept for sale. So depending upon which structure you want to construct, you have to go to the steel yard and appropriately purchase the steel sections. Now the IS 808-1989 provides us steel tables. Steel tables are the books which are containing the properties and dimensions of the standard varieties of steel sections to be available in the market for construction. So the steel table tells us that throughout the India, throughout the country, you will be having all these cross sections and all these standard dimensions of the steel sections. So that was an introduction of the 8 steel standard sections and the introduction of steel table. Friends, here we come across self-test 1, which is the formative evaluation test. Pause the video and write on a paper answers of the following questions. 1. State the common constituents of structural steel. What is the advantage of carbon and manganese? This is remembering level question. Second question, enlist 3 major steel manufacturers in India. Third, state long form of BIS. What is its role? What is the URL of its website? This is understanding level question. The fourth question, state and draw 8 standard steel sections. Remembering level question. After you have finished your work, you can continue for the further video. Now onwards, we will be taking a close look for the common steel sections which we use in steel structures, which is I section, then channel section, and then angle sections. So these I sections, standard I sections, are used as beams and columns in steel structures. So here we see an example. This is a column. These are the beam sections. So both of these sections are made up of I section. So this is a beam column system and all members are made up of I sections. These are the I sections as available. They are stacked in the steel yard, and you can see when you will visit the steel yard, you will see all the I sections stacked like this. Now this is the typical shape and geometry of standard I section as given in the IS 808. If we look at the geometry of this I section, we will see that there is a thin vertical plate-like component and there are 2 horizontal top and bottom plate-like components. Actually, these are not 3 separate plates. They are molded, as we have seen in the process of rolling, hot rolling, as a single section. There is no joint. So these 2 are the top flanges and bottom flanges, and the vertical component is called web. Usually this web thickness is much less than the thickness of the flange. Now you see some curvatures also here. So this is x-axis of symmetry, this is y-axis of symmetry. So the I section is symmetrical about its x-axis as well as y-axis. Now we will see some common varieties of I section. The same I section, I looking section, is designated in 5 ways. In the market, you will be designating every I section as ISJB, ISLB, ISMB, ISWB or ISHB. Let us see what is the meaning of these designations. IS Indian Standard, that is common for all. JB, so Indian Standard Junior Beam. For example, ISJB 200. After that comes a figure which is the depth of the section. So if it is ISJB 200, it means it is Indian Standard Junior Beam having total depth or overall depth as 200 mm. Second is ISLB, Indian Standard Lightweight Beam, ISLB 350. ISMB, it is Indian Standard Medium Weight Beam, ISMB 100. Then ISWB, Indian Standard Wide Flange Beam, that is ISWB 400 as an example, and ISHB, which is Indian Standard Heavyweight Beam, which is, for example, ISHB 500. Now here we see the extract of steel table in Indian Standard IS 808 1989, which is showing a table of properties. You can see here MB 100. MB means ISMB 100. Now you see some dimensions and then you see some sectional properties. In a single row, you will get all the properties for ISMB 100. The first property is mass, kg per meter. Then sectional area, the cross-sectional area of this I. Then dimensions. You get D, overall depth, B, the breadth of the section, then T, thickness of web, then capital T, the thickness of flange, average thickness of flange. Then there is slope of that flange, you say that it is tapered or inclined. Then R1 and R2 are the radii of curvature at this point and the other point. So these are the dimensions. Secondly, after these dimensions, you can get the values of sectional properties also. So based on these dimensions, we get Ix, Iy. Moment of inertia about x-axis, moment of inertia about y-axis for this ISMB 100. Then Rx and Ry, these are the radii of gyration, and Zx and Zy, these are the sectional moduli about x-axis and y-axis respectively. So in one row, you get dimensions as well as sectional properties of ISMB 100. Like this table continues for pages and you can get the values of all these standard sections of the 5 designations, and in those designations some 20-30 varieties of dimensions. So like that you get the data for the sectional properties and dimensions for all standard I sections in the steel table in IS 808 1989. So this was all about the standard hot rolled I sections. Now similar to I sections, we now come to standard hot rolled channel sections. The channel sections are also used as beams and built up columns. You can see this as the standard typical shape of a channel section. Now the IS 808 gives us this standard diagram of channel section. A channel section is similar to I section, but it is that means it is having flanges as well as a web. But the flange, the symmetry is different. You find that there is a C shape instead of I in the I section. So we are having x-axis as axis of symmetry, but y-axis is not the axis of symmetry. So this channel section is symmetric only about x-axis, but it is unsymmetrical about y-axis. So this is the example or the diagram showing a channel section. Similar to the standard I sections, the channel sections are also having four varieties. The first variety is ISJC, Indian Standard Junior Channel. ISJC 200 is the example. What is this 200? You can see here it is D, capital D. This capital D is this dimension of the section, which is the depth of the section. So you can get a channel section as ISJC 200, or you can get ISLC, Indian Standard Lightweight Channel, LC. Example is say ISLC 350, or you can get ISMC, which is Indian Standard Medium Weight Channel. For example, ISMC 100. Now we come across one more typical variety of this standard channel section. It is having 5 letters, ISMCP. What is the meaning? Indian Standard, M stands for medium weight, C stands for channel, but the P is additional. This P stands for parallel flanged. So this is ISMCP 100. What is the meaning of this parallel flange section? Let us look here. This section and this section, both of them are exactly same as they look like a C. But if you look carefully at the flanges, in this section you see a tapered flange. Tapered means its thickness reduces at its end. It goes on reducing gradually. So that is what is a tapered flange. So this channel section is having tapered flanges, but if you see here the flange is not tapering. It is parallel flange. It is having uniform thickness, and that is why this channel section, though it is also a channel section like this, it is different in the fact that it is having parallel flange. Now these parallel flange sections are usually more beneficial than the tapered flange sections, and nowadays this parallel flange sections are being used more popularly. So the designation of this is ISMCP. That P at the end indicates that it is parallel flanged. Now we get an example here. This is extract of steel table in IS 808 1989. This extract is talking about MCP. So this is parallel flange section. So let us take an example here. MCP 75. So you will get these sectional properties here. This is just the same, pattern is the same as in case of the earlier I section. So you get mass, sectional area, then the dimensions. Whatever dimensions are shown here, the width of flange, the depth of flange, the thickness of web, thickness of flange, and so on. All the radii of curvature and so on. So all these dimensions are given here. Sectional properties are also moment of inertia about x-axis, moment of inertia about y-axis, radius of gyration about x-axis, radius of gyration about y-axis, and sectional moduli about x and y-axis. One additional dimension comes in case of flange, this channel section. It is CY. What is this CY? Here C stands for CG, or center of gravity. So this channel section is unsymmetrical about y-axis. So its centroid is not at its geometrical center. So the steel table has to provide the distance of y-axis from the edge of the channel section. So this C dimension, centroidal dimensions or centroidal distances, these properties were not given or not required in case of I section, because it was already symmetric about x-axis as well as y-axis. Here it is symmetrical about x-axis, so no question of Cx, but it is unsymmetrical about y-axis, so they have given the distance Cy. Just look here, this distance is Cy. It is distance of y-axis, centroidal, I mean the y-axis from the edge of the channel. So these are the typical sectional properties of channel section given in the steel table. Friends, now we come to the last important standard steel section, that is standard hot rolled angle section. Now these angle sections are popularly used in roof trusses and towers. You can see this tower made up of all these sections or the members. They are network of members. All these members are made up of I section. Similarly, this roof trusses. So these are the standard I sections which are available in the steel yard or in the market. So the angle sections appear in the market only in two varieties. First variety is equal angle sections. The other variety is unequal angle sections. Now, as their name indicates, an equal angle section will have both of these legs as equal in their dimensions. So this is equal angle section. You will see this leg equal to this leg. So this is equal angle section. Here we see unequal angle section, whereas one leg is of length A, the other leg is of length B, and this is an unequal angle section. Now, whether it is equal angle or unequal angle, what is peculiar about angle section is that it is neither symmetric about x-axis nor symmetric about y-axis. So it is unsymmetrical section. Now whenever we come across an unsymmetrical section, the question of x and y-axis symmetry actually plays important role in case of compression members, in case of buckling. So in that case, the direction of buckling or direction of bending is decided by the x-axis or y-axis or the axis of symmetry. So there is a lot of relation between axis of symmetry and axis of bending. Now, because an angle section is unsymmetrical about x-axis as well as y-axis, when it is subjected to compression and if it is subjected to buckling or bending also, then it is likely to bend or buckle about x-axis or y-axis, or there are two more axes about which it is likely to bend or buckle. So those two axes are UU axis and VV axis. So because it doesn't have its own axis of symmetry at all, it has got four possible axes of bending: X, Y, U and V. And that is why the geometry as well as the working or the behavior of these unsymmetrical sections, the angle sections, becomes quite complex. So these here we see x-axis, y-axis, u-axis and v-axis. Now coming to the details of the steel table, the angle sections are designated as ISA, Indian Standard Angle. Now you can see in the steel table, instead of ISA, these three letters, they have shown an angle symbol. So both of them are equally the same. Then 30 by 20 by 3. This is an example. So they are showing an angle ISA 30 by 20 by 3. You are having three numbers. So 30 is one side, that is A, 20 is the other side, that is B, and 3 mm is the thickness. The thickness of both the legs is equal, same. So you get dimensions as A and B, A to be 30, 20, 3. Then R1 and R2 are the radii of curvatures. Then sectional properties are many. So you get Cx, Cy, these are the centroidal distances of x and y axis. Then you get Ix, Iy, Iu, Iv, because I told you that there are four axes of bending now. So you get four values of moment of inertia, four values of radii of gyration, and two critical values of sectional moduli. So the sectional properties also become little complex in case of the angle sections. This was a brief review of the angle sections and their mention in the steel table. We now come to the formative evaluation self-test 2. So please pause the video and write on a paper the answers of the following questions. The first question, draw standard eye section and show in it in the dimensions and properties of ISMB 125. So show the standard shape and from the steel table see the properties of ISMB 125 and show those actual values in the diagram. So the second is draw standard channel section and show in it dimensions and properties of ISMCP 75. The third is draw standard unequal angle section and show in it the dimensions and properties of ISA 30 by 20 by 3. All these three questions are of understanding type. So if you have finished your work, then you can continue with the video. So friends, here we come to the end of this video titled Indian Standard Course and Standard Steel Sections. The expected learning outcomes from this video were state metallurgical properties of structural steel and enlist major Indian steel manufacturers. Second was draw eye, channel and angle sections and interpret their properties with reference to steel tables. I hope you are able to actually do all these two things which were expected as outcomes. Then the key terms, so many key terms were used in this video. So I hope you have understood the things in the video. If you have not understood, if you have any doubts, contact your teacher for any doubts or queries. There will be a summative assessment quiz. So attempt that online summative assessment quiz as usual provided by the teacher in the Google quiz form. So with that, we come to the end of this video. I hope you enjoyed the video. Thanks till we meet again.